Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. There is another video in Engineers in Progress on uniform motion. The problems here can be reviewed and viewed for your engineering preparations, for review, for those who are reviewing for their licensure exams. You can also use this. For those who want to anticipate the solutions, you can do it, do it by pausing the video and solve the problems and compare the answers later. I hope that this will help you improve your analysis, simple analysis on uniform motion problems. So the concepts and principles are discussed in the preceding lecture and sample video problems. Problem 40. A group of tourists took a sightseeing bus trip of 240 miles and then boarded a plane, which took them to their next stop 550 miles away. The average speed of the plane was 16.5 times that of the bus, and the travel time was 6 hours and 15 minutes. 50 minutes. Find the average bus speed and the average plane speed. So the average plane speed is 16.5 times that of the bus speed. Take note of that. So the total travel time is 6 hours and 50 minutes. So this is 6 hours plus 50 over 6 or 5 over 6 hours. 6 and 5 over 6 hours. And it is equal to the travel time, bus travel time plus the plane's travel time. We know that time is distance over average speed or speed. So 6 plus 5 over 6 equals distance is for the bus 240 and the average speed is, just call it vis-a-vis. So it is equal to time for the bus, travel time for the bus, 240 divided by vis-a-vis, where vis-a-vis is the speed of the bus, average speed of the bus, plus for the plane, 550 divided by quantity, divide by 16.5 times vis-a-vis. So 6 times 6 is 36 plus 5, so 41 over 6 is equal to 820 over 3 vis-a-vis by adding 240 plus 550 over 16.5, and that's it. So 6 divided by 3 is 2, so this is 2. 2 times 820 divided by 41, so 820 over 41 is 20 times 2, so vis-a-vis is 40 miles per hour. That's the speed of the bus. And the speed of the plane is 16.5 times 40. So 16.5 times 40 is 660 miles per hour. So that's it for problem 40. For problem 41, Sam rode his bicycle 15 miles with a tailwind of 8 miles per hour, but in the same time rode only 3 miles of the return trip with the same wind now against him. How fast would he have traveled with no wind? So take note that uh, time with the wind, traveling with a bicycle, the time with the wind, Sam's travel time with the wind is equal to Sam's travel time against the wind. So let's set up that uh, equation. Time uh, with the tailwind or with the wind is equal to time with the headwind. And time with the tailwind is distance over effective speed or effective rate. The effective rate is the speed of some with no air minus plus rather the tailwind, which is 8 miles per hour. So it is equal to 15, the distance divided by v plus 8. So that's also time with the tailwind is distance traveled with the tailwind over effective speed with the tailwind equals T sub h is distance traveled with the headwind over effective speed with the headwind. So distance traveled with the tailwind is 15, then divided by v plus 8, where v is the speed of some with no wind, then equals 3 miles over v minus 8. So this is the effective speed against the wind or with the headwind. 15 over 3 is 5, so this is 5 and that is 1. So 5 over v plus 8 equals 1 over v minus 8. Cross multiply 5v minus 40 equals v plus 8. Since 5v minus v is 4v and 40 to the right plus 8 is 48, 4v equals 48. So v is 48 over 4. So v is 12 miles per hour. That's the speed of Sam using his bicycle with no wind. Problem 42. A rancher drove 40 kilometers per hour on a gravel road to the highway on which she traveled at 60 kilometers per hour until she reached a city that was 110 kilometers from home. If the trip took 2 hours, how far was the ranch from the highway? So the distance is the total distance traveled is 110 kilometers, and 110 consists of the length of the gravel road plus the length of the highway to the city. Then the length of the highway road, called that d sub g, is also the length of the gravel road. D sub g is also the distance from the ranch to the highway, and the length of the highway, which is from the end of the gravel road to the city, is the length of the highway to the city. So d is equal to d sub g plus d sub h. So we're looking for the length d sub g, and distance is 110. D sub g is average speed on the gravel road times travel time, which is, let's call it t sub g. So 110 equals 40 times t sub g plus the distance or the length of the highway is speed on the highway 60 times travel time quantity 2 hours minus t sub g, because the total trip took 2 hours. So this is the travel time along the highway. So 40 tg minus 60 tg is negative 20 tg transposed to the left, so 20 tg. 60 times 2 is 120 minus 110 is 10. So 20 tg on the left equals 10, where 10 is 6 times 2, 120 minus 110. So travel time on the gravel road is 1/2 hour, and therefore the length or the distance of the ranch to the highway is d sub g, and d sub g is 40 times tg. 40 times 1/2 is equal to 20 kilometers. Then finally, problem 43. Mr. Trammell traveled 870 miles to attend a company conference. He drove his car 30 miles to an airport and flew the rest of the way. If his plane speed was 12 times that of the car and he flew 48 minutes longer than he drove, how long did he fly? So the total distance traveled is 870, and this consists of distance when he drove his car plus the distance flying. on the plane. So d is distance of driving plus distance while flying with the plane. So 870 equals 30 plus d sub f. So 30 when he drove his car. So distance flying is 840 miles. And 840 equals speed of the plane times travel time flying. And also 30 kilometers at 30 miles is equal to average speed of driving the car times time, which is travel time of driving the car. So V sub d times T sub d. Then we equate it here because V sub f is 12 times V sub d, and the travel time flying is T sub d plus 48 over 60 as mentioned here. He flew 48 minutes longer than he drove, so the travel time while flying is driving travel time plus 48 minutes over 60 minutes per hour, so that would be in hour to be consistent. Cross distribute, so 840 equals 12 V sub d T sub d plus 12 times 48 over 60 or 0.8, that's 9.6 times V sub d. So V sub d T sub d is 30 from this equation here. 840 equals 12 times 30 plus 9.6 V sub d. So from here, we can now solve V sub d, 840 minus 360, 12 times 30. Then divide by 9.6. So V sub d is 50 miles per hour. Since the question is how long did he fly, so it is equal to, let's compute the travel time while driving, 30 over 50. So from this equation, 30 equals 50 T sub d. So T sub d is 0.6 of an hour. Then the total travel time while flying is equal to zero point 0.6, this time here, 0.6 plus 48 over 60. 48 over 60 is 0.8. So 0.6 plus 0.8 is 1.4 hours. So that's it for this video. I hope that you were able to follow the explanations and the solutions. So the solutions are not so detailed but explained so that you can start answering questions whenever you encounter problems on uniform motion by your own.